Today's topic is real numbers. So first of all, what is meant by real numbers? Means which numbers are called as real numbers. So real numbers is nothing but it is rational and irrational numbers are called as real numbers. Rational and irrational numbers are called as real numbers. Now what is rational and irrational? Which numbers are rational and which are irrational? Right? Now, which are rational and which are irrational? First, rational numbers. Rational. Rational means only a number which can be written in the form of P by Q. Which can be written in the form of P by Q where Q is not equal to 0. Then that type of numbers are called as rational numbers. Only a numbers which can be written in the form of P by Q, but not in the form of P by Q. That means, for example, 1 by 2 belongs to Q, means it is a rational number. Why? Because it is in the form of P by Q. And 3 by 4, yes, 3 by 4 is a rational number. Why? Because it is also in the form of P by Q. Now, is it 5? 5 is a rational number or not? Why? Because it is not in the form of P by Q. It is an integer. Now, is this integer is a rational or not? Right? So, 5. But that 5 we can write as 5 by 1. Now it is in the form of P by Q. 5 by 1 is nothing but 5 only. Or that is equal to the same 5 we can write as 10 by 2 also. After simplification we will get 5 only. So 10 by 2 is nothing but 5. Or also we can write as 15 by 3. It is also 5. So finally the 5 is also a rational number. Why? Because 5 we can write as in the form of P by Q form. So that means every integer is also a rational number. So every integers means all positive and negative including 0. So these are integers 0, 1, 2, 3 and so on, minus 1, minus 2, minus 3 and so on. These are the integers. So integers also rational numbers. Now next one, decimals. Decimal number, suppose 2.5. Is it 2.5 is a rational or not? The 2.5 we can write as 25 by 10. So that means 5 by 2. So it is also in the form of P by Q. So 2.5 we can write in the form of P by Q form. So the decimals are also rational numbers. Again, one more question. Is it all the decimals are rationals or not? All the decimals are rationals or not? Right? Now, decimals. Now, the decimals are two types. One is terminating decimal and second one is non-terminating decimals. Terminating decimals means, for example, 2.5, 3.68, 12.3429 and 1.0025. These are all terminating decimals because in these decimals the point right side part is called a decimal part. In this decimal part there is some limited digits. Here only one digit 5. In this 3.68 only two digits are there. Here only 4, here also only 4. That means in this terminating decimals the digit ends with any one of the digits. Suppose 2.5, it is ends with 5, ends with 8, ends with 9. So this type of decimals are called as terminating decimals. For example, 2.536 so on, 1.25468 so on. So like this, 10.345 so on. So these are non-terminating decimal. Why? Because these digits does not ends with any digit. Therefore, these are non-terminating decimals. These are terminating decimals. Again, In this non-terminating decimals, again these are two types. One is non-terminating recurring decimals and another one is non-terminating non-recurring decimals. Now what is recurring, non-recurring? Recurring is nothing but repeating. For example, 2.5555 so on. It is so on is there. That means it is a non-terminating only, but here one digit 5 is repeating. Or 3.626262 so on. So here also so on. That means it is also non-terminating, but here two digits 626262 is repeating. So these type of non-terminating decimals are called as non-terminating recurring decimals. But in this part 1.6348 so on. So it is a non-terminating only, but no digit is repeating. So it is called as non-terminating and also non-recurring decimals. These are also non-terminating only, but they are recurring decimals. Non-terminating recurring decimals, non-terminating non-recurring decimals, right? So non-terminating recurring decimals are also called as rational numbers, but non-terminating non-recurring decimals, these are not rational numbers, these are irrational numbers. So rational, irrational. Rational means only a number which can be written in the form of p by q. So this type of p by q, that means 2.55 a recurring decimal, 2.5 bar. So this type of questions we can change it to the form of p by q. In previous classes already we have done that 2.5 bar is changed into the form of p by q form. Right? So, but in non-terminating, non-recurring decimals, we cannot change it to the p by q form. So that's what they are not rational numbers, they are irrational numbers. So that means irrational number means only a number which cannot be written in the form of p by q, then they are called as irrational numbers. When number which can be written in the form of p by q, they are called as rational numbers. So rational and irrational are called as rational, and irrational numbers are called as real numbers. So that is the main topic, real numbers. Real numbers means they are only rational and irrational numbers. Rational number means only a number which can be written in the form of p by q, but irrational number means a number which cannot be written in the form of p by q. Right? Now the next topic is division algorithm. The next topic is division algorithm. Division rule, already we know that when there suppose for example 12 is divided by 4. If 12 is divided by 4, 4 3s are 12, remainder 0. Suppose 15 is divided by 2, 2 7s are 14, remainder 1. Suppose 17 is divided by 3, 3 5s are 15, remainder 2. In these divisions, 12, here 12 is called as dividend, 4 is a divisor, 3 is a quotient, 0 is a remainder. But in this division, 15 is a dividend, 2 is a divisor, 7 quotient, 1 is a remainder. Here in this division, 17 is a dividend, 3 is a divisor, 5 is a quotient, 2 is a remainder. Now the dividend, in this division, the dividend 12 is equal to divisor 4 into quotient 3 plus remainder 0, because 4 3s are 12, 12 plus 0 is equal to 12. Now here dividend 15 is equals to 2 divisor into quotient 7 plus remainder 1, because 2 7s are 14 plus 1, that is equals to 15. Now in this division, dividend 17 is equal to divisor 3 into quotient 5 plus remainder 2. So 3 5s are 15 plus 2, that is equal to 17. So that means in every division it satisfies one rule, that is division rule or division algorithm. Dividend is equal to divisor into quotient plus remainder. Dividend is equal to divisor into quotient plus remainder. It is called division rule. In this division also it satisfies. Dividend is equal to divisor into quotient plus remainder. Here also dividend is equal to divisor into quotient plus remainder. Suppose if A is divided by B, where B is not equals to 0, A is divided by B, where A and B are positive integers. If A is divided by B, then we'll get the quotient. The quotient is Q and the remainder is R. If A is divided by B, where A and B are the positive integers, the quotient and remainders will get, suppose, Q and R. Now, by using this division rule, the dividend is equals to divisor into quotient plus remainder. So A is equal to B Q plus R, means is nothing but A is a dividend, B is a divisor, Q is a quotient and R is a remainder. So this is called division rule, and also it is also we can call it as a Euclid's division algorithm. Euclid's division algorithm is nothing but dividend is equal to divisor into quotient plus remainder. Dividend A is divided by B, B is a divisor, and where quotient is Q, remainder is R. So dividend is equal to divisor into quotient plus remainder. A is equal to B Q plus R, where R is a remainder. Now R means remainder. Now remainder is depends on, that means in any division remainder is how much? That means remainder, the remainder value here it will be 0, here 1, here 2. So remainder is depends on, for example, remainder. Now we'll discuss about that remainder. Suppose any positive integer A is divided by, for example, B. If A is divided by B, where A is equals to, suppose, 5 and B divisor is equal to 2. That means A and B are any positive integers. Now A is equal to 5, B is equal to 2. Now 5 is divided by 2. If 5 is divided by 2, now what will be the remainders? If 5 is divided by 2, 2 2s are 4, remainder 1. Suppose if you take 5 in place of A, suppose A, we can take any positive integer. Suppose A is equal to, now we'll take 6. 6 divided by 2, 2 3s are 6, remainder 0. Suppose if you take A is equal to 7, 7 is divided by 2, 2 3s are 6, remainder again we'll get 1. Suppose if you take A is equal to 8, 8 is divided by 2, again 2 4s are 8, remainder 0. 2 4s are 8, remainder 0. If you take any other number, suppose A is equal to, suppose, 12, 12 divided by 2, that means 2 6 are 12, again we'll get remainder 0. That means finally the remainders, if any number, any positive integer is divided by 2, finally we'll get the remainders either 0 or 1. Either 0 or 1. Why? Because if any positive integer is divided by 2, we'll get the remainders only 0 and 1. Suppose if B is equal to 3, right? If B is equal to 3, now we can take A, suppose 5 only, 5 divided by 3, 3 ones are 3, remainder 2. Suppose 6 is divided by 3, 3 twos are 6, remainder 0. 7 is divided by 3, 3 twos are 6, remainder 1. 8 is divided by 3, 3 twos are 6, remainder 2. 9 is divided by 3, 3 threes are 9, remainder again 0. Suppose 10 is divided by 3, 3 threes are 9, again remainder will get 1. So finally, if any positive integer is divided by 3, any positive integer is divided by 3, the finally will get the reminders either 0, 1, 2, again 0, 1, 2, only 0 and 1, 2 are there. If any positive integer is divided by 2, we'll get the reminders only 0 and 1. Any positive integer is divided by 3, we'll get the reminders only 0, 1, 2. That means if any number is divided by b, where b is not equal to 0, that the remainder, then the remainder r is compulsory more than or equal to 0. Remainder is may be equal to 0 or more than 0, but compulsory it should be less than b, divisor, but not more than divisor. Why? Because here if divisor is 2, remainder 0 and 1. If the remainder divisor is 3, remainder 0, 1, 2, till 2 only, but not more than 2. Why? Because it is 3. Divisor is 3, the remainder it should be less than 3. Less than 3 means up to 2. So if any positive integer is divided by b, if a is divided by b, then the remainder is more than or equal to 0. Remainder either 0 or more than 0, but compulsory it is less than the divisor. This is a very important point. Remainder is always more than or equal to 0 and it should be less than divisor. This is the main important topic because the division algorithm or Euclid division lemma, it depends on the remainder only. The remainder is always more than or equal to 0 and less than b, but not less than or equal to also, because the remainder is always less than the divisor only. Right? So therefore finally we'll get a remainder. If a is divided by b, where b is not equal to 0, then the remainder is always more than or equal to 0 and less than the divisor b. For example, if a is divided by suppose 5, then what are the remainders? The remainder r is more than or equal to 0 but less than 5. Less than divisor is 5. Finally, therefore, if any positive integer is divided by 5, then what are the remainders are? Reminders are 0, 1, 2, 3, up to 4 only, but not more than 4. So finally, suppose if any positive integer is divided by some other number, suppose if a is divided by suppose 6, then what are the remainders? Remainder, actually algorithm, remainder is what? Remainder is more than or equal to 0, less than divisor. That means r is equal to 0, 1, 2, 3, 4, 5, up to 5, because less than 6. Less than 6 means only 5, up to 5. If a is divided by, suppose if a is divided by 9, then remainder is what? More than or equal to 0, less than divisor 9. Therefore remainders are 0, 1, 2, 3, 4, so on up to 8, but that means less than 9 only. So finally, if any positive integer is divided by some other number, positive integer, then we'll get the remainder. Means it depends on the remainder is how much? More than or equal to 0 and less than the divisor. It's a very important topic, very important point. Remainder is always more than or equal to 0, less than divisor. Right? Now, the division rule or Euclid's division. Euclid's division. Euclid's division rule or algorithm. Algorithm means what? It is nothing but a step-by-step procedure. So that stepwise procedure is called as Euclid's algorithm. The Euclid's algorithm is what? Simple. If A is divided by B, where A and B are any two positive integers, where B is not equal to 0, positive integers, and quotient, and the quotient is Q, and remainder is R. If A is divided by B, then we'll get the quotient Q, or remainder is R. Then the Euclid's division rule, A is equal to, A is nothing but dividend is equal to divisor into quotient, B into Q, divisor B, quotient Q, plus remainder R. So this is called Euclid's division algorithm. In this Euclid division algorithm, A is equal to BQ plus R, where R is a remainder. Already just now we discussed about this remainder. R is remainder. The remainder is always more than or equal to 0 and less than divisor. R is where R is more than or equal to 0. R is more than or equal to 0, less than divisor, that is B. Now, by using this division algorithm, Euclid's division algorithm, by using this division algorithm, how to find the HCF of the two positive integers. The next main topic is how to find the HCF of the two positive integers by using Euclid's algorithm. Right? Now, suppose for example, find out the HCF, highest common factor. HCF, highest common factor. HCF, highest common factor. How to find the HCF of any two positive integers? For example, we can take 12 and 8. What is the HCF of 12 and 8? Highest common factor. Highest common factor, right? For example, first of all, write down what are the factors of 8. Factors of 8. Factors of 8. 8 factors. What are the factors of 8? First one. Yes. 1 is a factor of 8. 2 is also factor of 8 because 2 4s are 8. 4 is a factor of 8 because 4 2s are 8. And 8 is also factor of 8. 1 8s are 8. 2 4s are 8. 4 2s are 8. 8 1s are 8. So 8 factors, 1, 2, 4, 8 are the factors of 8. Now 12 factors. Factors of 12. 12 factors. 1 is a factor of 12. 1 12s are. 2 6 are 12. 3 4s are 12. 4 3s are 12. 6 2s are 12. And again we'll get 12 1s are 12. 1 12s are, 2 6s are, 3 4s are, 4 3s are, 6 2s are, and 12 1s are. Otherwise, just write down 12 like this. 1 12s are 12, 2 6s are 12, 3 4s are 12, and 4 3s are 12. Other leave it off. Again we'll get same numbers, right? 1 2 3 4 6 12. 1 2 3 4 6 12. So these are the factors of 12. 12 factors. 1 2 3 4 6 8. 1 2 3 4 6 8. These are the factors of 12. Now 8 factors 1 2 4 8. 12 factors 1 2 3 4 6 12. Now in these two factors, 8 factors and 12 factors, here the question is highest common factor. It should be highest common factor. In these two factors, 8 factors and 12 factors, what are the common factors? Common factors. What are common factors here? 1 is a common factor, 2 is a common factor, 4 is a common factor. That's all. In these two, that means 8 factors and 12 factors, in these two factors, What are the common factors? Means 1, 2, 4 are the common factors. Out of these common factors, which is highest? 4. Therefore, highest common factor is 4. This is the basic method. Basic method. Why? Because highest common factors, first of all find out the factors of 8 and factors of 12. In these factors, first select all the common factors. Out of these all the common factors, whichever is highest factor is 4. Therefore, highest common factor HCF is 4. This is the general method, that is minimum basic method to find the highest common factor of the two positive integers. Now, the same to find the highest common factor only, but in division method. It is general factorization method. That means factors method, basic method, 8 factors and 12 factors. Select all these common factors and find out the highest common factor. Now, one more method, that is division method. In division method, find out the highest common factor of 12 and 8. Now, first of all, in these two integers, whatever the highest value is divided by the next value, lowest value. That means here 12 is divided by 8. That means in these two numbers, the 12 is highest, the 12 is divided by 8. If 12 is divided by 8, 8 ones are 8, the remainder is 4. 8 ones are 8, remainder is 4. Now check whether the remainder is 0 or not. Is it remainder 0? No, it is remainder is not equal to 0. Why? Because here remainder is 4. Now that remainder, whatever the remainder, that remainder is become as the divisor, and the previous divisor will become as the dividend. That means what? 8 is divided by 4. 8 is divided by 4. But the remainder, that previous divisor is divided by the remainder. 8 is divided by 4. 8 is divided by 4. 4 2s are 8. Remainder 0. Good. Now remainder 0. We cannot extend this. We cannot continue this system. Why? Because remainder will get 0. At the time of 0, in this stage, that means the remainder 0. At that time, whatever the divisor is there, the divisor is 4, then the remainder is 0. Now the 4 is called as HCF. HCF is 4. In this division, the highest value is divided by lowest value. First 12 is divided by 8, 8 ones 8, remainder 4, but remainder is not equal to 0. Now the previous divisor is divided by the remainder. 8 is divided by 4. Now we'll get remainder 0. The remainder 0, at this stage the remainder 0, at the time of remainder 0, whatever the divisor is there, that divisor is HCF, highest common factor. In previous case also, by using the factors, 8 factors and 12 factors, then also we'll get here the highest common factor is 4 only. Now in the division method also, we'll get the HCF is 4. That means this is called division method. Find the HCF, highest common factor. To find the HCF in division method, here also we'll get HCF is 4. This is one of the method. It is division method. The same division method, now we can change it to the division algorithm method, that is Euclid's algorithm. Right? Now here 8 is divided by, but already we know that if A is divided by B, then the division algorithm is what? A is equal to BQ plus R. That means dividend is equal to divisor into quotient plus remainder. Now here 12 is divided by 8. 12 is divided by 8. Now then the 12 is equal to dividend is equal to divisor into quotient. Now divisor is 8. The quotient is how much? 1. 8 ones are 8 plus the remainder is how much? 4. 8 ones are 8 plus 4, that is 12. So 12 is equal to 8. 12 is equal to 8 into 1 plus 4 is nothing but dividend is equal to divisor into quotient plus remainder. Now check whether the remainder 0 or not. What is the remainder here? 4. That 4 is not equal to 0. If the remainder is not equal to 0, then continue. What? Continue means what? The previous divisor now will become as a dividend. That dividend 8 is equal to, that means 8 divided by 4. 8 divided by 4 means dividend is equal to divisor into quotient. 4 2s are. Why? Because 8 is divided by 4. Here 8 is divided by 4. Now 8 is a dividend, 4 is a divisor. Now 8 divided by 4, dividend is equal to divisor into quotient. 4 2s are 8. Now 4 2s are 8. 8 plus how much is equal to 8? 0. 8 minus 8 0. That means 4 2s are 8. Remainder 0. Now the remainder is what? 0. Remainder is 0. We cannot continue the next step. So at this stage, what is the divisor? Divisor is 4. Therefore, HCF, highest common factor, is 4. This is the method, that is Euclid division algorithm method, to find the HCF of 12 and 8. Actually, highest common factors, there are two. First method, that is general method, find out all factors of 8 and find out all factors of 12, then select the common factors, and in that common factors, whatever the highest common factor is, that is HCF. That is basic method. But in division method, whatever the highest value is divided by lowest value, 12 divided by 8, divide the remainder 4, but remainder is not equal to 0, then that previous divisor is divided by that remainder. So 8 is divided by 4, will get remainder 0. If the remainder 0, now whatever the divisor is there, that divisor is called as HCF. The same method, division method, that division change into the basic algorithm, that is Euclid division algorithm. If A is divided by B, then A is equal to BQ plus R, where Q and R the Q quotient and remainders. Now if 12 is divided by 8, because 12 and 8, find the HCF of the 12 and 8. Now 12 is divided by 8, 12 is equal to 8 ones 8 plus 4. 8 ones 8 plus 4 only 12. So 8 ones are 8, the remainder 4. Dividend is equal to divisor into quotient plus remainder. Check whether remainder is equal to 0 or not. No, the remainder is 4. Remainder is not equal to 0. Then again continue. Means what? The previous divisor, now it will be becomes as a dividend. The remainder will become as a divisor. That means what? Divisor is divided by the remainder. Again 4 2s are 8. That means dividend 8 is divided by 4. Dividend is 8. Divisor is 4. 4 into 2 is equal to 8. So 4 2s are 8 plus 0 only 8. So now the remainder will get 0. If the remainder 0, in this stage, whatever the divisor is there, that is called HCF of the given two numbers. So this is the main basic method of to find the HCF of the two numbers by using Euclid's division rule or Euclid's division algorithm. Right? This is the main one of the topic of this first chapter, real numbers. Main first one, how to find the HCF of the two positive integers. Right? Now in the next topic we'll continue how to find the LCM and HCF and the different methods. Okay, thank you.